Hi, good morning, good afternoon, and good evening. Welcome to the Insighten webinar on client-side website security, the missing piece to a secure website. I'm Randy Fire. I work for Insighten with an expertise in marketing security, and I'm also joined by my co-presenters, Philippe Durake. He's a co-founder of Pragmatic Web Security and also holds a PhD in web security. We're also joined by my colleague Scarlett Wedby, and she's a solutions consultant with Insighten. So continuing on the theme of introductions, some of you will be familiar with Insighten, others perhaps not so familiar. Insighten provides a marketing security platform, which in essence and in short, protects our customers' most vital and critical digital assets, their websites and their mobile applications. On today's webinar, we're going to cover a few key topics. The first one being an introduction to client-side website security. What is it and why it's important? And also why a lack of client-side security controls has contributed to the massive success threat groups such as MageGuard have experienced. We'll also be offering some insight and guidance into how you can mitigate the risk of MageGuard and also other threat groups that are relying on web skimming as a means of stealing your customer data. Throughout the session, you'll be able to ask questions by inputting those into the chat box, so please feel free to do those at any point you can think of a question. We'll conclude the webinar by addressing those questions. To kick off, I thought it'd be really important to touch upon a few key trends. So the first trend that I'm going to discuss is the increase in cybersecurity spend. Gartner forecasts that in 2019, over $120 billion will be spent on cybersecurity. That's an 8% increase from 2018. At the same time as an increase in cybersecurity spend, there's also an increase in the number of data records being breached. Certainly not a correlation that you'd want to see. So I'm going to focus on third-party risk. And by no means am I saying that this would be a silver bullet, but it's an important consideration. One of the key tenets of cybersecurity is that you're only as strong as your weakest link. So whilst the other two trends are showing an upwards direction, unfortunately the focus on third-party risk is one that is showing a downward trend. KPMG released an annual cybersecurity report. In 2018, they found that 44% of respondents had no controls in place to mitigate the risk of third-party suppliers. That's an increase of 12% year on year. Furthermore, and bringing this back to relevancy for today's webinar, nowhere else than your website supply chain do these vendors enjoy an inherent amount of trust. And it's through the website supply chain there's been hundreds of thousands of incidents of data breaches and data theft. This becomes more concerning when you think of the latest research that Insighten have run. 67% of respondents are not planning on evaluating their current website security controls. And 46% of these enterprises still believe that they're at risk of a data breach. It's in this context that I hand over to Philippe to explain what is client-side website security and why it matters.
Thank you, Randy. Hi, nice to meet you, everyone listening here. So I'm going to talk about client-side web security, where it comes from. And I believe if you want to talk about client-side web security, then it's important to first talk about why or where we come from and what traditional web security actually used to mean. And with that, I mean, going back 15, 20 years, you all remember the age where you built PHP applications with a SQL database in the back end, and off you go. In such an age, you had server-side applications. The browser at that time, 20 years ago, with all respect for browsers, they were not very smart. They were mainly rendering engines showing some pages. So essentially in that world, all the security, all the things that mattered happened on the server side, because that's also what attackers started to target. That's where the interesting things were, the resources, the data, and what else they want to abuse. And over time, this actually started evolving. Browsers got more capable. We saw browsers evolve into this advanced application that it is today. And because of that evolution, browsers started to play a very important role in security as well. So browsers today play a crucial role in securing web applications because the server is going to delegate certain responsibilities to the browser. Of course, as browsers evolve, so did web applications. Today, well, most of us no longer build PHP applications backed by a SQL database, but we build modern JavaScript-based applications, Angular, React, Vue, all those things. And of course, such an application has a different set of requirements and features that are being used as well. So I think it's safe to say that security got a lot more complex today. And I think that complexity is part of the reason that Randy mentioned that less companies might be spending the necessary amount of effort on securing those things just because of the changed landscape. And I think you can see that change very well in the OWASP Top 10. So the OWASP Top 10 is essentially a document released by the OWASP Foundation, which main goal is to strive to raise the standards in web security that we have today. All the resources are open, free, and it's essentially a treasure trove of information about application security. But what's mainly interesting here to see is that the top risks in the OWASP Top 10 are about server-side vulnerabilities, because we still have these problems today, and they are still very, very dangerous. A1, A2, these things definitely matter for server-side security. But what's very interesting here is that you see client-side security creeping in here. You have the usual suspects. Cross-site scripting is, of course, about client-side security. It's a problem that is being exploited on the client side. Yes, that is in there. But also things like sensitive data exposure. Today, that's no longer exposing data in a database or on a network. It's also exposing data to a third-party piece of code running in your application. And that's definitely very important. Same thing for using components with known vulnerabilities. That used to be a server-side thing where you had that with your Maven dependencies. Today, you have a very similar problem with your NPM dependencies running in your client-side application. And this image, actually, to me, this whole picture shows that client-side security is definitely important. And that's also one of the things I often talk about with clients when discussing web security. All right, so it's essentially about this third-party JavaScript code. And this third-party JavaScript code is definitely one of the major risks we're facing today. So as you can see on the next image, today we depend on quite a few of these third-party vendors offering some kind of service. So on the right, you see all of these logos. They're kind of picked at random, and there's no real intention of putting someone here, but all of these offer a service. You can integrate that into your website and off you go. You have, all of a sudden, you have the ability to track marketing statistics about your users just by including a piece of third-party vendor code. It's that simple. So you might think, from a functionality perspective, yes, it is that simple. You include it, it works, you're happy, and off you go. But if you look at the security angle here, what you actually see is that now you're building this dependency on a merchant, on a vendor. So you're loading code from there, and you actually have no real clue what you're loading. So maybe what you load is legitimate code. Well, hopefully it is, but in some cases it will be malicious code. Maybe the attacker was able to modify it on the network. Maybe the attacker was able to modify it on the server. But essentially what it comes down to is that you're pulling in something in good faith. You're hoping that these guys, whatever vendors you're working with, are giving you the code that you expect and not something else. And that is essentially, in a nutshell, what this client-side security or these client-side risks are about. And of course, if you want to look at this, a picture like the one here on the left doesn't show you the full architectural view. So you need to view this in a larger architecture of a web application.
Philippe, thank you for covering those two slides. Just a couple of comments. So, going back to the OWASP slide, which really talks through the consideration for third-party JavaScript, that's a real problem. It's something that's on the rise. I see commercial websites adopt as much as 50 different third-party JavaScript code on sensitive pages, such as their checkout process. Furthermore, and Philippe, I know you're going to touch upon this, but just a couple of comments on why this is a major risk. Too many of the current security capabilities that are focused on protecting your website are either back-end or server-based. So that's why I think Philippe's next slide, talking through a website architecture, is really going to help put this into some context.
Yeah, absolutely. So I really like your comment that this is a rising trend, and that's absolutely the case. And well, we can go in, well, we're not going to go into details on why that is, but it's an historical evolution. And today, if you want to integrate one of these services, there's not much choice. Even if you're building a simple blog and you want to include discussions from a service provider, it's going to be a piece of code you include in your application, just like that. And this image here shows why that is a problem, because your application is essentially what's running on the right. It's the server running the application, serving it to the browser, and that's going to be your secure perimeter. That's going to be your network, your data center, your virtual servers, doesn't matter, but essentially what you have under control. And now what you serve to the customer ends up on the laptop you see on the left. And that laptop is essentially the computer of the user. And that's where your application, essentially your skeleton of an application, is going to be composed into what it really is supposed to be. And in this case, in this day and age, this means that the application on the client side is going to pull in stuff from analytics. It's going to pull in stuff from a social media server like Facebook integration or Twitter integration or whatever. It's going to pull in some ads if you have advertisements. And those ads are probably going to pull in ads from God knows where. And in the end, you're building an application out of building blocks, and you only control kind of the skeleton, but not the full picture of where these components actually come from, what they are, and what they're supposed to be or allowed to do in your application. And that's essentially a very clear picture of what the problem of client-side web security is. It's these dependencies on these third parties that we actually have very little control over, unless you take specific action, of course. So we've seen this in practice. The most recent case, I believe, the most newsworthy case is MageGuard. MageGuard is, well, I can talk for hours about MageGuard if you want to, but I'm not going to do that because I believe the tool cuts us off after 1 hour. So let's keep it short. But MageGuard is essentially a group of attackers targeting applications, web applications, mainly through client-side attacks. And their goal is skimming credit card information. They want to grab the customer's credit card information from that logout form or that pay form. And they do it on whatever website they can find. You have different groups doing that, and each group has their own tactic or their own way of approaching websites. So the really newsworthy stories are a group that targets high-profile websites. And you may have heard about this very newsworthy case, and that was the Ticketmaster case. So essentially, the attackers figured out that they could attack Ticketmaster and they could grab your credit card information if you purchased a ticket from there. And they found out that Ticketmaster, to attack them, they had a third-party vendor offering some insights from marketing. And they figured out that, hey, if we can breach that vendor, we can modify the marketing code and it will be loaded in the Ticketmaster website and we can start grabbing credit card information from there. The code to do that, the malicious code, was 22 lines of JavaScript. That's it. 22 lines of JavaScript to grab credit card information from every customer that visited that website while that code was running. And that's essentially what is going on there. And this is a very nice detail that shows how determined these attackers are. They figured out like, hey, Ticketmaster is a very lucrative target. We can grab a lot of stuff from here. So what if we can grab even more? And they looked for a second service provider to attack. They figured out how to break in there, how to modify code, and with that, they got even a stronger foothold into the Ticketmaster website.
Philippe, thank you for the overview on what happened at Ticketmaster. Just a couple of comments here. I know we're discussing MageGuard. However, the issue of web skimming doesn't just impact e-commerce companies. It's a very real threat that's posed to banking organizations or insurance companies as well. And also, one of the things I hear from regular customer meetings, quite often I'm sitting across info security teams and also digital marketing teams. It's not just malicious data theft. Quite often I'm asking how they could potentially resolve issues of accidental or perhaps deliberate data leakage through approved supply chain vendors. And to put this into some more context and bring this to life, a large-scale study conducted in 2016 across 3,300 websites found that over 8% of these were leaking sensitive data that's inputted into contact forms. The data leakage occurred through marketing vendors, advertising technologies, and also analytics tools. The concern here is that these weren't vendors that were compromised. There's no indication of compromise, it's just the way the internet works. If you go back to Philippe's example of the architecture, this is something that every website is at risk of. And now bringing this back to MageGuard for a moment. So one of the leading researchers into MageGuard has suggested that MageGuard are looking to adapt their techniques, their tools, and also the data that they're trying to capture and steal from your website. So it's not just about credit card data anymore. It also encompasses login credentials and any other sensitive information. I also feel that the adaptation has already come, and it's not just data that's at risk. Philippe, I think you're going to talk through quite a prominent example that impacts user experience.
Yes, absolutely. So what you mentioned is absolutely correct. So it's not necessarily about stealing credit card information. The reason they do that is because that's information that has real monetary value on the black market, and it's easy to sell. But you need to remember, the moment that the malicious code runs in your application, it can do whatever it wants. It can hide a part of your application. It can add illegal transactions to your application. It can steal user information, mislead the user, whatever. Or in the example here, the text help example, it can essentially, first of all, break the user experience and then do some more nasty things. So what happened here? This is a piece of software. Well, this company built a piece of software called Browse Aloud, and it's essentially a single script you integrate, and that takes care of all the accessibility needs for your website. Something very important for government websites. They have rules to abide by. They have to be accessible to other citizens, so they have to be accessible by blind people and things like that. And this service provider handles that for you. No more messing with the UI and making sure everything is compatible. They do that for you just by integrating their code. So that's the whole setup. Things seemed to work pretty fine until a few months ago, and somebody discovered that something weird was going on. And what happened is that this Browse Aloud software was compromised on the servers of this company. And the attackers added a few lines of code, again, not to steal credit card information, because there's no credit card information on the government website. They have taxes for that. They don't need credit cards to get your money. Instead, what they did here is they started mining cryptocurrency on the user's computers. So first of all, they broke the user experience, but then second of all, they actually steal resources from the user by starting to mine Monero cryptocurrency in JavaScript. There's CoinHive offers this JavaScript. You simply give it your key for your wallet and you put the script somewhere and it will run as fast as it can, consuming CPU, consuming power and generating heat, meanwhile resulting in a sluggish user experience for the user. So yes, it's definitely about more than just credit card data.
Thank you, Philippe. And just to add to your comments there's some fresh research that was released this morning or yesterday evening. The research has highlighted that some of the top websites in terms of traffic, over 50,000 of these have already been compromised by a malicious CoinHive script. So users visiting this website, they were visiting the website and their user experience was impacted. They had no idea that they were mining cryptocurrency. Instead, they had a negative sentiment around the brand website they were visiting. Hopefully after that summary, this question should be somewhat rhetorical. Should you evaluate your current client-side security capability? If for whatever reason you're still uncertain, I think there's a couple of checks that you can ask yourself to ascertain whether you need to do something. The first would be, what is the data that you want to protect? And can it originate from your website? Can users visiting your site input sensitive data that otherwise, if on your network, you would look at protecting? Cybersecurity is high on the agenda for many companies. So I read a lot of annual investor reports, and one of the key operational risks that keeps getting highlighted is that risk of cybersecurity, that risk of a cybersecurity data breach. And the reason why this is a risk is it has a huge brand impact. And the brand impact, as you all know in this digital age, has moved to social media channels. And not only is it a concern for your investors, but it's also a concern for your customers. So the smallest potential or even the smallest of incidents can quickly go viral, impacting upon your brand sentiment. And then, for all of the attendees on the site that work for companies, if you were to go onto your website and review the privacy policy, I'm very confident that it will say something along the lines that you take all reasonable measures to protect your customer data. just check again. Are you doing everything that you can? And thirdly, Poneman Institute in 2018 ran some research, and 59% of respondents confirmed that their organizations had suffered a data breach due to a third party. So how are you mitigating the risk of your website supply chain? Do you have the right controls and processes in place? In the conversations I have in terms of why customers are now looking at reviewing their security capabilities on their website, it really falls into three categories. The first one is that they've experienced a website data breach. So this one is perhaps a very obvious reason to react. And some of the other reasons are, hey, we've just seen a headline and we've seen that it was one of our competitors or that it was a large brand. And we just cannot be the next brand that suffers this type of data breach. Third reason is that security stakeholders now have a very strong and robust business case for doing something and investing time in mitigating client-side security risks. So some conversations that I've had with the largest e-commerce companies in the world, I've been told, hey, we're really happy and grateful for MageGuard. Taken aback a little, I heard them out and they explained, up till now, they've been submitting quarterly reports to their board, evaluating risk. And unfortunately, it's quite a reactive process. Now with the incidence of MageGuard, it's really given them ammunition on taking this forward and introducing some mitigation capability. So the question I then get asked is, hey, we're aware of the risk and we want to do something about this. So what can we do?
Absolutely. What can we do? Well, hopefully by now you're scared enough to realize that you need to think about these things more or less seriously. And in my opinion, there's quite a few things you actually can do. Some of them will be easier than others. Some of them have specific purposes, but I want to talk about four more generic ones, four security mechanisms supported by the browser, and then Randeep and Scarlett are going to take you to a more application-specific solution that you can integrate without needing specific support from the browser. Let's talk about the first one, origin-based isolation. Origin-based isolation is actually quite interesting. It's the oldest mechanism around, and it's been in browsers for about 20 years. And essentially what it comes down to is if you have two contexts in the browser, for example, a main page and a frame in that page, if they come from different origins, so essentially if their domain is different, or the scheme or the port, but usually it's the domain, if that is different, then the browser will simply isolate these from each other. They will, if they load a script, it will be in their own context, but it will not be able to influence the page of the other context. And that's essentially what the cross over the arrow here means. It's a fully isolated context. It can be completely isolated. This is very useful if you want to isolate a more sensitive part of the application. Let's say you have an application with some public features, but nothing really sensitive going on, and you have a part of the application that allows the user to, let's say, launch a webinar. That part you could isolate into a sensitive component, essentially running under a separate domain. In this case, account.example.com or webinar.gotomeeting.com or whatever. And because of that isolation, you can sort of guarantee that the application is more secure. First of all, you can prevent the loading from third-party scripts in that sensitive component, because you can say like, no, this is really sensitive. I'm not going to load advertisements and analytics and stuff in here because I want to protect the data that is in here. Of course, and a second benefit is if the main site would be attacked here, if www.example.com gets compromised, loads a malicious script, that script will not automatically be able to manipulate or read the data inside that protected component. That's the good side of what you can do here. Of course, there's a few limitations. If I explain this on a PowerPoint slide or a webinar image, this is really easy to say like, yeah, just put things in separate components and you're good to go. Of course, this requires your application to be able to do that. If you need to be able to identify components with different trust levels, you need to be able to separate them easily. And that by itself is not something you do in just a blink of an eye. This is something you need planning for. You need some kind of a client-side architecture, and you need to work towards this goal over quite a bit of time. But in my opinion, this is one of the strongest defenses we have. Unfortunately, it's not that easy to integrate, especially in an existing application. All right, that was number one. Number two, essentially kind of builds on top of that. So number two is the HTML5 sandboxing technique. Essentially, it builds on the same concept of isolation, but it takes it to the next level. Here, the example here, we're not going to isolate something we trust more or something we want to keep away from the main application. Well, in a sense we do, but in this case, it's untrusted. Think of an accounting application showing invoices to an accountant. Essentially, the invoices are submitted by the user, and those things might be considered quite dangerous. You have no idea what you're pulling in, you have no idea whether they contain script code, and you don't want that running here. With sandboxing, you can add this attribute to your iframe, and you can tell the browser, sandbox this iframe. Show the invoice in the iframe and sandbox the whole thing, as in don't allow script execution, don't allow it to interact with my page, and don't allow it to do these things and that. I'm not going to go into detail here, but you get the idea. So essentially, a sandbox gives you behavioral control over what can happen inside that context. And that's one of the major strengths of this mechanism. That's, for example, also what Google uses on a Chromebook to show you documents from Google Docs. They render that in a sandbox iframe to ensure that it cannot do anything malicious outside of that iframe. Sounds good? Yes, it's a very strong mechanism. I'm a big proponent of sandbox iframes. Of course, the whole point of a sandbox iframe is to isolate untrusted content. So if you're not really loading untrusted content in your application, you're not going to have a very good use case for a sandbox. And even if you think like, I'm going to load something that I don't fully trust, I'm going to include a YouTube video, for example, and I'm going to sandbox that, that's going to be quite tricky because these things actually check for the sandbox and they don't like being put in the sandbox because of those restrictions. If you integrate YouTube on your website, they don't want to be isolated. They want to see what else is going on and get some analytics for that from that page and do something with that data. So again, sandboxing, very strong, very useful in certain use cases, but might be a bit limiting if you want to include third-party components with that technique.
Thanks, Philippe. Well, I come across a few questions when discussing anything that involves an iframe. The first one that I hear from business stakeholders is that, hey, we've invested a lot in third-party technology. It delivers fantastic business results, and they just don't work in an isolated environment. They need DOM access to be effective and deliver these strong business results. The second thing that I hear is that this has the potential to really kill performance. And for a lot of the companies that I speak with, website performance is at the top of their digital agenda. So just keen to check with you, is that something that you hear, and do you find that sometimes that can perhaps impact adoption of these techniques?
Yeah, those are valid concerns, absolutely. So what I believe, let me try to answer your two questions separately. So first of all, let's talk about the performance issue. So performance-wise, yes, that might be an issue if you're loading like 10 iframes on your website. That's not going to be very pretty. It's not going to work very well. However, places where this does work very well is if you don't look at the more public side of websites or the public services, but more at the enterprise applications that already do a lot of heavy lifting, then adding an iframe here and there with a sandbox probably doesn't matter too much performance-wise. It's not the worst place to be in. That's part one. The second part of your question was about third-party code and the business impact. And again, I think the YouTube example is maybe a good example there as well. But you're right, it's going to have an impact, and you're going to have to figure out for yourself whether you can live with that impact, yes or no. Maybe some parts of the application are so sensitive that they maybe don't need to rely on that third-party code. But of course, it highly depends on what that code actually does. There's going to be cases where there's no way to isolate that, but there might be other cases where you do have the option to do that. But you're right; those are definitely valid concerns. All right, let's move on to the third mechanism. The third mechanism is fairly new. It's called content security policy. And content security policy, you can see the image here. It's not a very simple mechanism. So let's start at the beginning. Let's start at serving the application. So whatever happens when the user goes to your web application or website, is that the server is going to serve up a page. And that page is going to include all the resources that need to be loaded, the scripts, the style sheets, the videos, the images, and so on and so on. With CSP or content security policy, the server can deliver a security policy alongside your web page. So it sends a response header to the browser in step 1 here, saying, hey browser, I want you to load this page, but I also want to enforce these restrictions on the content. And essentially, the restrictions, the policy you can provide is very configurable. So you can tell the browser, I want you to load this page, but script files can only come from these and these hosts. And if you want to load an image, you have to check that it's coming from these or these hosts, and everything else is not allowed. And that's essentially what's going to happen in step 2 and 3. If you include a library, the browser is going to check that CSP policy. Is that library in there? Oh yeah, that CDN is whitelisted with this file. That's good. I'm going to load that library. Same for analytics. Oh, is that type of analytics whitelisted? Oh yeah, that file is whitelisted. This matches the URL. I'm going to execute that script code. But in case that the attacker manages to inject additional script code through a cross-site scripting vulnerability, for example, the browser is going to try to load that. Hey, do you want to load a script from evil.example.com? And the browser is going to check like, there's a CSP policy here. Oh, look at that. Evil.example.com is not whitelisted, so I'm not going to load that script. And the browser will simply refuse to load that script. And that's essentially, in a very brief nutshell, what CSP does. CSP is definitely a good security mechanism. It is something that has the potential to really strengthen the client-side security of your application. However, yeah, sure, go ahead.
Sorry, Philippe, I just thought of a question, something that comes up a lot in terms of research into CSPs. Adoption is still pretty low. And in the conversations I'm having, one of the reasons that gets thrown at me is that it does require highly skilled development staff. And for a lot of companies, that is a resource that is quite scarce, and it comes at a premium. It really slows improving client-side security down. So one example, I was speaking to a leading e-commerce company. They'd requested a CSP over 12 months ago, and what they were finding is that this kept getting put to the bottom of the priority list. The business stakeholders want these developers to focus on user enrichment and really drive business results. In your experience, what are the things that limit adoption of measures such as CSP? Whilst you've described it as being very powerful, what's your experience? Is that consistent for you as well?
Yes. Again, sounds like definitely a valid point. I also do come across cases where business requirements take precedence over security features. But I tend to agree. CSP is fairly complex. Like I said, we only touched upon the surface of CSP here. There's a lot of details going behind the scenes of how do you do this and how do you do this securely without having a policy that can be bypassed. So yes, CSP does require skills from the developer. What I strongly suggest there is, if you want to go with the CSP route, is this should not be something you do once and you deploy in your DOM. That's something that should be inherent to your development cycle. And essentially your main development teams should also learn how to write decent CSP policies so that they can keep them up to date as the application evolves. Otherwise, you're going to run into trouble with stuff breaking anyway. All right, so that brings us to the fourth mechanism. And the fourth mechanism is, again, a browser-based security mechanism called sub-resource integrity. And this is one you might have heard of because in the whole MageGuard craziness, this mechanism has been referred to quite a bit. So what is it about exactly? This is actually fairly simple to explain, even though the slide looks a bit intimidating. So in step 1, the server is, again, serving your HTML page containing your application. And what you're going to do as a security mechanism here, instead of simply telling the browser, load the script from there, you're going to tell the browser, by the way, when you load the script, the checksum, the cryptographic hash of this file should be exactly this value. In practice, it's going to be a SHA-384. So you calculate the hash once, or somebody else does this for you, and you say this file corresponds, and the contents of this file corresponds to this unique hash value. And you give that to the browser. And then the browser is going to process the file, and he's like, oh, I need to load a script from that host. I'm going to fetch that script, that library in this case from the server. That's step number 2. Note that the attacker is not in play yet. So step number 2, the script file comes back to the browser, and the browser is going to calculate that cryptographic hash again. And that hash will only be the same value as provided by the server if the contents of the file are exactly the same as they have been seen before by the server. And when these contents are exactly the same, then the file will be loaded. But when the contents are not exactly the same, the checksum will be different, and the browser will refuse to load that file. And those changes can be, for example, if you add a single white space to the file on the server of the CDN, the library file, the checksum will be different. Of course, a white space is probably not that malicious, so that would be a problem if that breaks. But on the other hand, if the attacker goes into that CDN, modifies that one library, like we have discussed examples before, and that file gets served to the browser, at this point, the browser will trigger step 4 and will say, like, with all due respect, but I'm told to load the file with this checksum, and what I'm loading is something else. I'm refusing to load that. And that is what SRI is about in practice.
Philippe, thank you for running through those 4 techniques. I think a lot of them would certainly add a lot of value to client-side website security. And before I hand over to my colleague Scarlett, who's going to be talking through what marketing security is and how it's set up, I did want to touch upon a few, one key story that I hear all the time. And it's, just to make sure that we're not saying that third parties are bad. So the businesses that I speak to, they derive a lot of value from these third parties. It helps them make their websites more effective, and it generates more revenue for their respective organizations. So there have been more than a number of occasions where organizations have been forced by their InfoSec teams to remove all third-party JavaScript from the checkout process. The result of that, on review in a 4 to 6 week period, unfortunately, it's shown a steep decline in website performance and the KPIs that are measured, such as how much revenue is the website generating. When that happens, the conversation really shifts from, it's not just good being a secure website. How can we be a secure website that optimizes our business performance? So the conversation becomes, hey, security, how can you enable us to use these third-party scripts in a safe way without relying on our development teams, without impacting site functionality and performance, and in turn, business results? So I'm just going to switch over to my colleague, Scarlett, who's going to cover the marketing security proposition.
Sure, thanks, Randeep.
Sorry, bear with me, Scarlett, just going to give you presenter rights.
Yep. All right. So, Philippe and Randeep have extensive knowledge around, web security, marketing security, but what does a solution look like? And I think, when Philippe was going through kind of the 4 different methods that are commonly used by practitioners today, it all kind of comes back to being very resource and development heavy. Well, with our solution, Privacy by Insighten, we allow you to have a platform that doesn't require you to have heavy, intensive developers or engineers on a daily basis, trying to evaluate scripts, trying to manually go in and take a look at, well, I think that we're using this technology, but I'm not really sure, or hey, do you remember when, our marketing team deployed this code? No, I don't, but it's still on our website. So we have very streamlined workflows that you can use to evaluate what's currently on your site, how you want to manage it, and then develop kind of a data governance moving forward. So just to give a high-level overview of how Insighten's privacy works. So we are monitoring all network requests that are going across the web from your site to your different third-party vendors. So essentially, we act as if we are a mini firewall once privacy is deployed. And the first step here, when you go into Insight's privacy module, we have gateways, so enforcement gateways. And gateways are basically a technology that sits between your website and requests to other networks. So just as the name suggests, it is a gateway keeper that provides a point for data flow into and out of your website. It gives you control, and you can create as many of these as you like. I'm just going to go ahead and click on one that I've already created here. And what essentially happens here, and we're going to talk about this within List Manager, is you can gather a list of trusted domains or domains that maybe perhaps you do not want data flowing into, including your own top-level domains through privacy. So these domains are always trusted to make sure that your site functions correctly. And we do that through our enforcement mode. So we have two different flavors here. The first one, Observe. Observe mode is going to track all of your scripts requests, and this is going to collect those different scripts and domains already firing on the site and populate within List Manager, which I'll talk about in a second. And this puts them into an uncategorized item. So Observe mode is really valuable when you are a new customer deploying privacy, because when I speak to customers and prospects, oftentimes they don't know all of the different scripts that are currently running across their different web properties. Well, using enforcement mode and Observe specifically, you can gather all of that information to make those appropriate decisions as far as who are the scripts that we do want running on our different web properties, and which ones do we not actually passing data to. So let's jump over to List Manager. So after you run Observe mode, all of the different scripts across the different properties within your environment are going to populate here. And from this point, you can determine, okay, so which domains am I going to allow data to flow into? You know, my Google Analytics. Is it going to be my Certona? Is it not going to be Act On? So what domains are we always going to allow? Which ones, no, we're not going to allow those domains to pass any sort of information, right? And you can run that as frequently as you need. So once you've been able to identify those different domains that you want data to flow to versus which ones you don't, we then can decide to, okay, I now want to actually enforce what I have created within List Manager. So within Enforce, you're going to recognize and block those scripts and requests that you've defined within List Manager. And then from there, you can decide what is going to be whitelisted as well as blacklisted. So which of those scripts are going to allow to be served, right? And then from a blacklist perspective of those sites, we will block those requests, but you can still have those requests as far as being able to see from an auditing perspective. So still have the ability to have visibility as far as, okay, even though I have a governance as far as what domains I'm going to allow to pass that data to, which ones I'm not going to allow. And then also SSL. So again, another security enforcement here, right? The ability to block requests that come to your site that do not have SSL enforced. So I think that, again, if security is of importance to you, you now have 3 mechanisms by which you can enforce whatever is most relevant to your organization. So the next step here is, okay, well, I've determined what my governance is. I've put together the different sites that I'm going to allow my data to flow to, but now I need to create a governance workflow, and that's where our data governance comes into play. So as you see here, I just have a workflow 3 basic steps. So here is my gateway. Yes, I'm going to turn on my data governance. And then this is where we get into data patterns. So how are we going to manage those different data patterns, right, within our gateway? So we have 3 different versions here. This is going to determine how we handle data requests. So blocking is going to prevent requests with matching patterns, so data recognition patterns. Masking is going to remove and replace matching patterns with a hash character. And then we also have redaction. So thinking about stripping out requests with that matching pattern. And then also, as Randeep and Philippe both talked about, commonly used patterns, we have that out of the box. So thinking about email addresses, social security numbers, things of that nature. But in many conversations that I have with organizations that are in healthcare industry, for example, they may have certain pieces of information, medical records, things like that, where there is a specific pattern. It's not within our custom pattern section out of the box, but you can enter that in here, right? And you can use regex to enforce it. And then finally, how can you actually test this in real time? Well, we can use a proxy such as Charles or Fiddler, or you can just simply look at the network request within a developer tool itself, right? So you could, in theory, look at those network requests, inject some malicious code here as you're going through the site prior to deploying privacy within your site itself. And then afterwards, what does that look like? So if you have malicious code scripts that you want to test out, just to see the actual tool working, we have those types of controls put into place as well. So I definitely want to leave questions and as well as a wrap up from Randeep and Philippe. So Randeep, if you want to take controls back.
Hi, Scarlett, just taking some controls back.
Sure.
And Scarlett, thank you for that. And in this diagram that you can see on your screen, it's something that we're going to distribute, and so not something that I'm going to talk through in any detail at this point. But it shows the flow of decisioning and the whitelisting of the domains and the scripts that you want to allow on your website. So just to summarize, the choices that you have as an organization. So hopefully you feel compelled to implement client-side website security. Of course, there's the 4 techniques that Philippe has alluded to and explained quite well. I'm going to leave you with some food for thought in terms of, before you decide what to do, some of the questions that you need to ask. And I think some of these are around the viability of these tools and techniques for your organization. So can you, check with the third parties that you work with? Can they support these measures? Just to highlight one example, sub-resource integrity, it is contingent on third-party vendor support. That vendor needs to allow JavaScript versioning. And quite often I have conversations where companies have completely abandoned these types of projects because the third parties that are integral to their businesses don't support this. It means it's unfeasible to implement as a solution. Furthermore, do you have the skill and resource to implement and manage these techniques? As Philippe rightly says, these are not easy techniques. And you also have to think implementing them is one thing, but who's going to manage and maintain them moving forwards? And quite importantly, what would the business impact be on website performance, functionality, and also ongoing maintenance? And for those that are considering the marketing security approach, the key question to ask is, who would be the product owner? So there are multiple use cases, and we've just touched upon a security use case. Product owners can come from e-commerce, security, compliance, and even marketing. Now we have a few questions, so we're going to move over to Q&A. Okay, sorry, bear with me, I'm just pulling the questions up. So I think, Scarlett, these are going to be directed towards you. So we have a question, and it's asking, how do you block requests that your JavaScript does not have access to the browser network? And I think it's a twofold question. If MageGuard attacked a third party who was whitelisted on your system and they send the user's information via iframe, would you be able to catch it and block it, and how?
Yeah, that's a really good question. So I think it goes back to first going into observe mode. So one, within the list manager, we can basically do an audit across your different web properties. Two, you can also manually enter in different domains or different vendors that you want to always allow those domains to have that particular code, served onto the page itself. And then finally, at the same time, if there are vendors that you never want to allow, you have that drag and drop feature where you can just enter in that code and from there ensure that data is not going to flow out to those particular domains. And then finally, I would say, within the data governance piece itself, using custom patterns. I think that there is easily, ways that you can enter in those patterns. And then finally, which we didn't talk about today, I wanted to make sure that we had time to wrap up and ask questions, but you can add in also custom domains, which are trusted domains, as well as untrusted domains. So depending upon what those trusted domains are, or what the custom domain is that you want to block or allow, those are all different types of controls that we can ensure, to prevent against a MageGuard attack, to help ensure that data flows or piggybacking is not occurring.
So thank you for that, Scarlett, and hopefully that answers the question that was put to us there. We have the next question that we have is, which of the 5 choices is most performant? I'm going to start by answering this, and Philippe, if you want to make any comments, please feel free to do so. So the marketing security platform, there's a few key principles that we try and achieve for our customers. One is that of security, the other is around performance. So if you think of website performance, much of that performance, like security concerns, has shifted to the client side. So Insighten not only helps with that, but we have performance-specific features that improve, load time and page performance. And Philippe, from the 4 techniques that you went through, is there something that you wanted to address?
Yeah, sure. It's a difficult question to answer because they serve different purposes, of course. So it's hard to talk about which one is the most performant. But let me try to answer this in a more or less generic way without going into all the details again. So essentially, the first 2, origin-based isolation and sandboxing, rely on some content being loaded in a separate context. So you're going to have separate page loads there. So yes, there will be some noticeable performance. What that exactly means depends, of course, on your website, what you're loading, and how often you want to do that. On the other hand, CSP and SRI are both mechanisms you distribute alongside the page, so the performance overhead there is practically nothing. So essentially, you distribute the policy alongside your main response. You have a few extra bytes, but it's not going to be that much. And from that point on, the browser does this natively. It's implemented right within the browser. It doesn't take too much time checking these things against the policy. So the performance overhead there will be practically 0.
Thank you for that, Philippe. There's another question that's come in, and this is around a specific breach. So the newegg.com data breach. This was first-party JavaScript. So the question is, would a CSP have helped or prevented this data breach?
Honestly, probably not. Let me talk about why. So CSP would have whitelisted that file. It would have said in the policy like, oh yeah, files from our own website are probably okay, so we're going to load those anyway. With SRI, you would have been able to specify this is the checksum of the file, and if the file would have been changed, that mechanism would have detected that. So it seems that SRI would be a very good mechanism there. But if you think about where the files are located, chances are that the file containing the checksum is stored next to the file that is being loaded with the checksum. So if the attacker can modify one, he can probably also modify the other and change the checksum in the source file as well. So if that's the case, you lose protection there again. What would have helped is CSP also allows you to define where outgoing connections can go to. And if you would have had a strict CSP policy, you maybe could have prevented or made it a lot more difficult to leak the information to the outside. But the malicious code would still run, and there probably would be a way to leak it anyway, one way or another.
Thank you for that, Philippe. And the next question, I think this is one for Scarlett, and we are running short on time, so it's probably going to be the last question. So the question is, can Insighten be deployed and configured by security teams, or does it need specialist web development knowledge?
Good question. So I would say that no, it doesn't require heavy development. As I walk through the platform, and if people want a deeper dive to understand a little bit better, I'm happy to take questions offline or provide a more in-depth demo. But no, essentially, it's deploying JavaScript code, synchronously in the header one time, and then essentially creating those different audits, the data governance component within the privacy platform itself. So you saw that I really didn't have to dig into any code. We have a simple workflow. It's drag and drop as far as the types of domains that we want to allow data to flow to. So very straightforward, and we fully support you as far as that initial training.
Thank you for that, Scarlett. And just to conclude today's session, you may have seen a link posted to all from Christy Stewart. You can follow that link, so if you want any further information on Insighten, or if you wanted to request a proof of concept, please get in touch. Alternatively, on an individual basis, you will hear from an Insighten team member who will follow up and see if you had any additional questions further to today's session. I hope this has been useful and is compelling the security stakeholders and the digital teams to do something about client-side website security. Thank you all for listening.
Thank you.
Thank you. Have a nice day.